All right, our next section here, once again with systems of equations, systems meaning two or more, is going to be by substitution. First off, we were doing these things by graphing, but substitution is an algebraic way of doing it. Yeah, so it's using algebra instead of graphing, because sometimes algebra can be faster. Sometimes graphing's faster. All depends upon how ugly it is, right? Now, you did this last year in grade 10, like your last chapter was systems, but it was doing them graphically or algebraically. Now, algebraically, there's two different ways of doing this. One is called substitution, and that's what we're doing today. Substitution. The other one was called elimination. This is where you eliminated one of the variables. We're not doing that one today. Today we're just going to do substitution. So substitution is where you take one and you substitute it into the other. Now remember, this is going to be two variables, right? Two variables and two equations. That's what a system is. Two variables means x and y, means it's going to be like a graph, or it could be an x and y point. So to do it by substitution, here's what you want to do. First off, isolate either x or y, your choice, in one of the equations. Well, you know what? Go for the easiest one if you can, in one of the equations. In one equation. I don't need the s. Then what you're going to do is you're going to substitute it into the other equation. Once again, look for the easier one to substitute in. Now, important, you have to substitute it into the other one. If you substitute it back into itself, everything disappears. It's kind of useless. Okay, so once you've done that, you're going to either solve for x or y, either one. Either x or y. And then you're going to solve for y or x. In other words, you're going to solve the other variable. Oh yeah, because remember it's two variables. And then if it does ask you to check, you need to check in both equations. So both equations. I'm not going to ask you to check all these things, but if it does ask you to check, you got to make sure it works in both. Okay, so let's go back to what we started with, a linear quadratic system. Remember, 1 times 2, we could get up to 2 solutions. 2 or maybe 1 or maybe 0, right? It is possible. So my first step is I isolate either x or y. Well, we can either solve for y equals or x equals. And I could do it over here. I could solve for x. No, that's more complicated. Go for the easier one. And you know what? Simply move the y over to the other side. You get positive y, right? Minus 10 is equal to 5x minus 10. So I've isolated y is equal to 5x minus 10. I'm going to plug that in over here. It's got to plug into the other equation. Okay, so that's going to plug in over here. So here's what I'm going to get. X squared plus x, right? Those don't change. Minus 2 times, now it's going to be 2 times this whole thing, right? Because y is equal to 5x minus 10. 5x minus 10. Now that's equal to 0. Okay, so this is now an equation just in x. I can actually solve this, right? Here you're isolating one of the variables. Here I'm actually solving. Okay, let's expand all this junk out. What do we get? X squared plus x minus 10x minus 10 plus, so plus 20 is equal to 0. This is x squared minus 9x plus 20. This factors. Two numbers multiplied to 20, it's got to be, they multiply to 20 and they add up to negative 9, which means they both have to be negative. Negative 4, negative 5, there we go. Usually if you're going to get down to a quadratic here, it's usually something you can handle. It's not that bad. Okay, so what do we got? We have x minus 4 bracket x minus 5. Remember, if I'm going to do this by factoring, that means the x value is either positive 4 or the x value is positive 5. Now, that's the x value. What's the y value? Oh yeah, so I've substituted in, I solved for x. Now I need to go back and solve for y. And now I can plug it into either one of these equations. You know what? Go back to the easiest one you did here. Remember, y is equal to 5x minus 10. Okay, plug in 4. 5 times 4, 20. 20 minus 10, which is, that means y value is 10. So this is an x and y point. Right? If I've already isolated y is equal to, I don't need to show that step. Same thing here. Let's take 5, plug it in. 5 times 5 is 25. 25 minus 10, 15. So the y value is 15. So that's an x and y point. So if it asks you to verify, you got to do it in both the equation and so this one and this one. Okay, so I'm just going to get lazy. I'll just do this first one because let's see. So 5x minus y. So 5 times x minus y, which is 10. is equal to 10. So this is 20 minus 10 is equal to 10. Yeah, that works. Now let's plug it into the other one, right? X squared, so 4 squared, plus 4 minus 2y, and y was 10. Is that equal to 0? Well, let's see. We got 16 plus 4 minus 20. That's 20 minus 20. Yep, it works. It works in both of them. If I was to do this same one, same thing's going to happen. Look, 5 times 25 minus 15 is equal to 10. Yeah, that's going to work. And if I plug this into here, remember the x value is 5. 25 and 5, which is 30. 2 times 15, 30 minus 30. Yeah, it's going to work in both of them. Okay, I'm just too lazy to do all that right now. Besides, we want to get on to the next question. Now, here's the thing. Notice I solved for y equals, right? I could have solved for x equals. I had a choice. And you could either do it in this one or this one. You know, go for the easier one. Had I solved for x equals, right, I would have had 5x is equal to, I'll move the y over, 10 plus y, and then I want to go and divide by 5, right? I could have solved for x is equal to 10 plus y, all divide by 5. And then what would my answer have been? Okay, then I would have substituted into here. So I'd square it plus the number minus 2y's. So I would have had this equation. 10 plus y over 5 squared plus 10 plus y over 5 minus 2y is equal to 0. This is ugly. I mean, yes, it'll still work. I could expand this stuff out if you really love fractions and you like doing binomials, but you know what? It was way easier to do it the other way. So there's 4 ways I can either solve for x in this equation or y in this equation. I can solve for x in this equation or y in this equation. I could have solved for y is equal to and substituted that in here. But go for the easiest one. Start with the easiest equation and look for something that's got a coefficient of 1. That way you can avoid your fractions, right? Okay. So let's try another one here. It says determine 2 integers such that the sum of the smaller one and twice the larger one is 46. Also, when the square of the smaller one is decreased by 3 times the... Oh man, what is this? Okay, write a systems of equations. First off, I need 2 variables. What are my 2 variables? We could call them x and y, but I'm talking about a smaller number and a larger number. Okay, so let's say x is the smaller number. Okay, and do you want to say y is the bigger one? Y is the other number, the bigger number. Now, it says they're numbers, right? So I don't know if it could be a fraction, decimal. Oh, no, 2 integers. Oh, they're not numbers. They're actually integers. Good. That's important because that means no fractions, no decimals. Integer. Okay. So there's my 2 variables. However, I need 2 equations. Now it says the sum, that means adding, the smaller one, so x, plus twice the larger one, x plus 2y, is means equals 46. There's an equation. Yay, it's linear. That's nice. Also, when the square of the smaller number, okay, so x squared is decreased by, I'm going to subtract off 3 times the larger one, so 3 times y. The result is means equals. This equals 93. Okay, so this one is a quadratic. I could actually solve for y equals if I really wanted to, but there's my linear and there's my quadratic. Fantastic. Solve it algebraically. So you can start with this equation, solve for x or y. Solve for this. You know what? Let's solve for the x because it's a 1x. This is going to be fantastic. Look, leave the x on this side, move the 2y over. So minus 2y, minus 2y. 46 minus 2y. That's what I'm going to substitute in. So this is going to substitute into the x right there, right? X is equal to this. Now, I could have solved for y is equal to, but I would have been dividing by 2. I would have got a fraction, right? Let's not do that. So I'm going to take that and I'm going to substitute it in. Here's what we got. X squared. Okay, so it's 46 minus 2y squared minus 3y is equal to 93. Okay, so let's try this. Yikes, what's 46 times 46? 46 squared, whew, 2116. 46 times 2, which is 92, doubled. What? 184. Yikes. Plus, oh, hang on, 184y plus 2y times 2y. 4y squared minus off 3y is equal to 93. Yikes. Okay, that's a lot. But this is an equation. It's just in y. I can actually solve. Let's put this in order. 4y squared. How many y's? Minus 184 minus 3 is minus 187 y's. Yikes. 2116, 2116, take away 93, right? Because I'm going to subtract off 93 from both sides. 3202. So plus 2023 is equal to 0. I am not factoring this thing. You know what? I'm going to the quadratic formula. You remember? Oh yeah, x is equal to negative b plus or minus the square root of b squared minus 4ac. Oh, over 2a. Oh, that's terrible. You know the quadratic formula. You remember this thing. Okay, so you know what? I'm just going to go to my handy dandy calculator. Let's plug it into the quadratic formula. Okay. Quadratic formula. 4, negative 187, 2023. Okay, here's what I get my two answers. So it's not x, it's actually y, right? So y is equal to 29.75 or y is equal to 17. Okay, so I get two answers, right? No. Remember, we were always talking about this. You either get two answers, one answers, or no answers. Sometimes you could get integers. These are integers. I cannot have, yeah, that's not right. So it's not an integer. Oh, yeah. So go back and actually check with the question. Now, 17, that's not the answer. That's the y value. So what's the x value equal to? Well, I don't know. Well, I could go back and plug it into here, or I could plug it into here. Go to the easiest one. And you know what? You've already isolated x. Do this. It's way faster. X is equal to 46 minus 2y. So in other words, x is equal to 46 minus 2 times 17. So in other words, 34. X is equal to 12. So in other words, x value is 12, y value is 17. Hang on, is that answering the question? Solve the system. It says when the square is, the result is this. So determine the two integers. Here we go. So here's my answer. I haven't actually answered it. To answer the question, I should say the two integers. The integers are 12 and 17. Now, it didn't say check it, but you know what? I'm going to quickly check it because, let's see. It says, let's go to the equation. If you do the sum of the smaller one, which is 12, and twice the bigger one, plus 34, that does add up to 46. Yes. And let's do this one. The smaller one squared, which is 144, minus 3 times 17, which is 51. This minus this is going to give me, it does equal 93. It does. Now, I didn't actually show the check, but it's not that hard to plug them in and check it. Okay, so these questions on page 451, these ones have to do with substitution. And remember, you can either solve for x equals or you can solve for y equals. Either one. And go from the easier equation into the harder one. Alrighty, good luck with these ones.